Problem 18. In the figure above, AE is parallel to CD. Segments AD and CE intersect at point B. What is the length of segment CE, so this entire segment? Well, there's two triangles given to you in the diagram, and in order for two triangles to be similar, they need to have two sets of congruent angles. And here these two angles in the middle are congruent because they're vertical angles. And since CD is parallel to AE, you have a set of alternate interior angles going on. Angle A and angle D are congruent to each other. So what I'm going to try to do is I'm going to try to copy these triangles over. I'm going to kind of align the corresponding parts. So angle B in the bottom triangle kind of corresponds to angle B in the top triangle. So here's B in the top triangle. Now in this top triangle, this angle A and this angle D are congruent to each other. So I'm going to kind of label, since A is in the bottom corner, D is in the bottom corner, and then I'm going to label C right there. I'm told that AB is 10 in the diagram, BD is 5, BE is 8, and since this is 10 and this is 5, those two sides have a ratio of 2 to 1, which means if BE is 8, BC has to be 4, because this triangle is quote-unquote half as big as this triangle. So the question says, what is the length of CE? Well, CE is the same as CB plus BE. If I add up these two line segments, CB is 4, BE is 8, so it looks like line segment CE is going to be 12. Problem 11, they tell you that lines KL and M intersect at a point, and they tell you that angle X plus angle Y equals angle U plus angle W. And there's all sorts of sets of vertical angles. Angle U and angle Y are vertical angles, and they're congruent to each other. Angle X and angle T are vertical angles, they're congruent. And angle W and angle Z, they're vertical angles, and they're congruent. So they want to know how many of these statements below are true. So what I'm going to do is this. I know that angle U is equal to angle Y. So these two are equal to each other. So if I take out U and plug Y in its spot, I have X plus Y equals Y plus W. If I subtract Y on both sides, I get X equals W. So there's number one being true. All I did was substitution. Since U is equal to Y, I took out the U and I threw in Y in its spot. So number one is true. Now, besides having vertical angles, I also have straight lines. So for example, line M is a straight line. So that means the angles above, if I add them up, have to equal 180. X plus Y plus Z equals 180. And the angles below, W plus U plus T, they also have to equal 180 because they form a straight line. Well, since I know that X plus Y is equal to U plus W, basically what that means is I can take out the U plus W and put in X plus Y. This and this have to be equal to each other. So what I can do is I can simply subtract the equations together because these two will cancel. 180 minus 180 is 0. That would give me Z minus T. And then if I added T to both sides, I would get Z is equal to T. That makes number 3 equal or true. But to get any type of relationship between angle Y and angle W, it doesn't exist. I know I have vertical angles, so if this top angle is y, angle u is also equal to y, and I know that since x and t are vertical angles, x and t have to be the same, but there's no relationship between angle w and angle y. So that's why here I claim the answer is letter B. Only 1 and 3 are true. Problem 18, they're giving you two isosceles triangles. This triangle on the left and this triangle on the right. Here you're told 180 minus z equals 2y, and you're told y is equal to 75, and the question is, what is the value of x? Well, since you're told y is equal to 75, I'm going to plug that in. I'm going to have 180 minus z, and that's going to be equal to 2 times y, or 2 times 75, or 150. Minus z equals 150, and here if I subtract 180, I have negative z equals negative 30, so here I'm going to get z is equal to 30. Well, since that triangle on the right is isosceles, and angle z is equal to 30, I know that since those two sides are equal, the two base angles are also going to be equal. So this angle here and this angle here, or in this diagram, these two bottom angles right there. Well, since I know z is equal to 30, I can figure out the base angles by going 180 minus 30, which is 150, dividing that by 2 to get 75. So in this triangle on the right, the two base angles are each 75, and then angle x is supplementary to angle 75 because they lie in a straight line. So here I can go 180 minus 75 to get here, x is equal to 105. In problem 20, in triangle ABC, the measure of angle B is 90 degrees. So I'll label a right triangle, angle B is 90 degrees. It says BC is equal to 16 and AC is equal to 20. Triangle DEF is similar to triangle ABC, where vertices D, E, and F correspond to A, B, and C respectively. So what I'm going to do is I want to draw this other triangle, and it says vertices D corresponds to A, E corresponds to B, and F corresponds to C. So here's my similar triangle. And it says each side of triangle DEF is 1/3 the length of the side of the corresponding triangle. So since BC is 16, EF is going to be 1/3 of 16, or 1/3 times 16, or 16/3. And the question says, what is the sine of angle F? Well, in order to find the sine, we're going to use a rule from geometry, SOHCAHTOA, where I know the sine of an angle is equal to the opposite over the hypotenuse. Now, these two triangles, they tell you, are similar in that each side of the bottom triangle is 1/3 the side of the top triangle. So in order to find the sine of angle F, I would have to find the side opposite F, so that would be side ED, and divide that by the hypotenuse, in this case FD. But these two triangles are similar. And since they're similar, the sine of angle F is going to be exactly the same as the sine of angle C. See, trigonometry, the ratios, the fractions are true. If I do, for example, 20 over 16, since this bottom triangle is 1/3 the top triangle, it's basically going to be 1/3 of 20 over 1/3 of 16, which is basically equal to the same ratio of 5 to 4. If I reduce this, 20 thirds over 16 thirds, and I multiply both the top and the bottom by 3, I'm still left with 20 over 16. So basically the sine of f is the same as the sine of angle C. And that's the trick to the question, because to find the sine of angle C is a lot easier. Here the sine of angle C is opposite over hypotenuse. Well, you already have the hypotenuse. You already have the 20. To figure out the opposite, I can use either the Pythagorean theorem, a squared plus b squared equals c squared. Remember, letter C stands for the hypotenuse, so that's 20 squared. Here, a is going to be 16 squared, and b is going to be what I'm solving for, the opposite. So I'll call that x squared. So here I'm going to have 16 squared, which is 256, plus x squared equals 400. Here, if I subtract 256, here I'm going to get x squared equals 144. So when I take the square root of both sides, I get x is equal to 12. So here I know that the x, the side opposite angle C, is going to be 12. So that's going to be 12 over 20, and that reduces to 3 over 5. And since this is a grid question, you can either fill in 3 fraction 5, or you can fill in 0.6. Also, from sophomore year, if you remember your 3, 4, 5 Pythagorean triple, the hypotenuse is 5 times 4. This leg is 4 times 4, which means the bottom leg has to be 3 times 4, or 12. Either way, the sine is 3/5 or 0.6. Problem 23, they give you these two angles that are acute, and they tell you the sine of angle A equals the cosine of angle B. Now, why is that important? Well, sine and cosine are what we call cofunctions. Sine and cosine, just like tangent and cotangent, and secant and cosecant. Those are groups of cofunctions. And cofunctions are complementary angles. I always remember that as co and complementary both begin with CO. So cofunctions are complementary. So, for example, the sine of 30 has to equal the cosine of 60, because 30 and plus 60 equals 90, and complementary angles are two angles whose sum is 90. So basically, since they're telling you the sine of A equals the cosine of B, they're going to add up to 90 degrees. So I know angle A plus angle B is equal to 90. Well, now I'm just going to do some substitution. Since A is equal to 4k minus 22, I'm going to throw in 4k minus 22 for A. And then since B is equal to 6k minus 13, I'm going to plug in 6k minus 13 for B. And now I'm going to solve this equation for k. So I have 4k and 6k gives me a 10k, negative 22 and negative 13 and negative 35. And here, if I solve this equation for k, I'll add 35 to both sides. I have 10k equals 125, or when I divide both sides by 10, k is equal to 12.5, or answer choice C. So just remember, sine and cosine tangent and cotangent, secant and cosecant, those are all sets of cofunctions. And cofunctions are complementary angles. They add up to 90 degrees. Problem number 17. In the above triangle, the sine of x is equal to 0.6. And this question is asking you for the cosine of y. Well, what I'm going to do is this. I'm going to turn 0.6 into a fraction on my calculator. And the way you do that is you press the math button on your calculator and choose option 1. So here, 0.6 is the same as 3/5. So I know because of SOHCAHTOA that the sine of an angle is equal to the opposite over the hypotenuse. So since the sine is 3/5, that means I'm going to label the opposite side of angle x. So here's angle x. The opposite side is going to be 3, and then the hypotenuse is going to be 5. So what does that missing side turn out to be? Well, either I can remember the 3, 4, 5 Pythagorean triple, or I can do a squared plus b squared equals c squared. C is the hypotenuse, so it's 5 squared. So here I can have 3 squared plus, maybe I'll call that z squared. I'll call this side z. Z squared equals 5. So I have 9 plus z squared equals 25. Here, when I subtract 9 on both sides, I get z squared is equal to 16. So if I take the square root of both sides, z is equal to 4. But if you can remember the Pythagorean triple of 3, 4, 5, it a lot of times makes finding sides of triangles a little bit easier. So, the question now is asking me for the cosine of angle y. Well, cosine is equal to adjacent over hypotenuse. But here I'm dealing with angle y. So if I label my picture with angle y, I know the opposite is going to be 4. The hypotenuse is still going to be 5. And that makes the adjacent side 3. So here the cosine of y is equal to adjacent, which is 3, over the hypotenuse, which is 5. So here you go. The cosine of y is equal to 3/5. So this is a good question. You can enter in 3 fraction 5, or you can convert that back to a decimal, which is also 0.6. Here the sine of x equals the cosine of y, because again, those are cofunctions. But here, our answer is either 3/5 or 0.6.